for June 26th with Miss Chrissy, and I have my helpers with me again today. We have
Abel, Nora, Evie,
and Evie. Very good. And there might be a brief appearance from Luna if she decides to get up off the couch. So today we are doing our second STEM video for the month of June for our summer reading program, One World, Many Stories. And as you can see up here in front, I have all of the supplies that we're going to need, and we're going to make bottle rockets today. It's a multiple part activity that's going to hit a bunch of the letters that make up STEM. Okay, so the first thing we're going to need is our bottle to make our rocket. So this is just an empty 2-liter bottle that once had soda in it. I've got vinegar and baking soda. Okay, these are big jugs. You won't need quite this much. That just happens to be what I have at home. I have a measuring cup with a spout on it. I have a tiny square of paper towel. And I have a tablespoon measuring spoon to help scoop the baking soda. And then a cork. This is just a cork from like a wine bottle or something like that. And we'll talk more about what we're going to do with that in a little bit. So, what we're going to do is actually 2 parts that you can even make into 3 parts if you wanted. So STEM stands for science. Does anybody know?
Technology.
Technology. What do you think the E stands for?
Education.
That's a good E word.
Engineering.
Engineering. And what do you think the M stands for?
Math.
Math. Very good. And you know what? Sometimes people do STEAM activities, which is S-T-E-A-M. Nora, what do you think that A might stand for? You don't know? Sit up. You're hiding behind the baking soda. Anybody know what that A might stand for? It's a tricky one. We don't do it all of the time. Yes? It's tricky.
Algebra.
Oh, that's a really, really good guess. That does start with an A. That is part of math, so it makes sense to go with this category. But the A actually stands for art. And so, the first part of our activity is going to be the E in STEM, which we have done in multiple of our videos. It's the engineering part. So, in order for our bottle rocket to launch, it needs a launch pad. And so we are going to engineer a launch pad using some building materials. Okay? The building materials that we have chosen to use are back here on this table. We have Lego. We have a flat base plate, and then we have just a variety of bricks. We just brought some of our tubs of Lego up from the basement to be able to do this. You can use whatever material you have available. You can use Lego, you can use Tinker Toys or Lincoln Logs or popsicle sticks, whatever you can use, whatever you want to use to build just a little base to hold our rocket when we go to launch it. That's the E part. That's the first step of this activity. The second step is going to be the S for STEM, science, specifically chemistry. We're going to create another chemical reaction, just like we did in our last video when we made elephant toothpaste. And so we're going to combine vinegar and baking soda to create a chemical reaction inside this rocket that's going to make it launch into the air. Now the third part is optional, and we're not going to show you how to do that part, but that is something that you can do if you want on your own, and that's the A for art. You can decorate this baby however you want. You can make it look like a real rocket ship. You can color it, you can paint it, you can glue little paper fins on the side so it looks like the wings of a rocket. Whatever you would like to do. So that would be the third part, and that is optional for you to do if you want. So let me explain what the science behind this is. So we have sodium bicarbonate, which is better known as baking soda. Okay, and that is a base. Then we have an acidic acid, which we're using as vinegar. Okay, and that's the acid. It's very heavy. You think you can lift it up? Whoa, don't dump it out. There we go. Good job. Let's put it back down. Good job. You're very strong. Okay, so when we combine these two things, a chemical reaction is going to take place that creates carbonic acid. And essentially what that means is it's going to take the chemicals inside of that bottle and break them apart to create carbon dioxide and water. If you've ever made a volcano, or if you've ever played with vinegar and baking soda before, when you put them together, it bubbles and fizzes and comes up just like our elephant toothpaste did last time, okay? The carbon dioxide is creating a gas and releasing as a gas. And so, when that gas builds up inside this bottle, it's got to go somewhere. If we block the opening to the bottle, it won't have anywhere to go, and it will continue to fill up the bottle until eventually it pushes the cork that's going to be in the bottom of the bottle out. And thanks to Newton, Isaac Newton, we know that the laws of motion say that for every action, there is an equal and opposite reaction. So the action of that gas pushing that cork out is going to create the reaction of the bottle shooting up into the air. So that's the science behind what we're doing. And the engineering part is going to be us building the launch pad. And the art part can come later if you want to decorate your bottle. So let's get started on the engineering and start making our launch pad. All right? Here's what we constructed. It's just a square out of some Lego bricks that we had. So this is our prototype. So let's test our prototype and see if we need to make any revisions, right? All right, Abel, grab that bottle and dump it upside down inside there, because that's how we're going to launch our rocket. Now, it kind of tilts over a little bit, which means when the reaction of the cork shoots out, the bottle is going to go in the opposite direction, so it's going to shoot that way instead of going straight up. So let's troubleshoot. Let's think of some ideas. Let's brainstorm some ways that we can make this better. What are some things that we could do? What might be the problem here? Evie?
Maybe it's too small. It can't like fit around like this part.
Yes, maybe it's too narrow. It's not wide enough for this. What else could it be?
Or maybe when this was sideways, it fitted. Then when someone pushed it,
it tipped over. Could be. Could be. Nora, what do you think?
Maybe it's too tall. Maybe if we make it like a little smaller, it will fit.
Yeah, maybe that could be it too. Maybe it's a little taller.
Yeah,
like maybe if the bottle fit a little more down and it could touch the bottom,
kind of locks in
it
the
would
little stuff.
kind of lock it in. That's right. So let's try that. Let's take a layer of Lego off. Everybody can help. Just take one layer off the top. Whoops. We'll get it. Now let's try it. Nora, you want to put it in there and try it this time and see if that's any better? Go ahead and let go of it.
That's a little better.
It's a little bit better. It doesn't tend to tip over as much, but it is still a little not quite
Maybe
right.
take another layer off.
Yeah.
So, I think it still needs to lock in a bit.
I think it's still a little too tippy. Maybe we just need to make it whiter. So we're gonna go back to the drawing board and get this worked out just right. After some discussion and trying to figure out if we should make it wider or longer or shorter or taller, we did finally figure out what we were gonna do to make the best launch pad we could. What we ended up doing was we took out one row of bricks right here just to give it a little bit of space so that when we tip it over and put it in, there's just enough space for that bottle to rest right along there. So we have our launch pad. It took some engineering, it took some prototypes and some revising, some brainstorming on how to figure it out, but that's what it takes to be an engineer, right? So our next step is going to be to prepare our rocket for the science part, the chemistry part, to launch it. To do the launching part, you should go outside. It will be a big launch. And last time we went outside, we went in the grass because we were doing food coloring. This time, we're going to go out to the driveway and onto concrete because the vinegar that we are using is considered an acid. It's a very mild acid that we use for cooking and those kinds of things and cleaning around the house, but it could affect your grass. So to make sure that it doesn't kill any of the grass in your yard, it's probably best to do this one on concrete. A driveway would be a perfect spot for that, or a patio. So to prep the bottle, we will gather our supplies back up again. All of the supplies. The other thing with the launching part, it's best to have the adult do the launching part, because if it happens to pop and launch before you get over there, it's best to have the adult do that part, okay? So, in order to get your rocket to launch, you're going to want to take your vinegar and get about 1 to 2 cups of vinegar. So this is a 2-cup measuring cup. I'm just going to fill it up to about 2 cups. And then you're going to very carefully pour your vinegar into your bottle. If you have a funnel like we used last time, that would be very helpful. The spout on the measuring cup is going to help. You can also always do it over the sink as well. So we're going to try this here and see how big of a mess I make.
That's funny because you know you're going to make a mess.
Sometimes STEM and science is messy. And that's okay. Okay, so that's 2 cups of vinegar poured into our rocket.
That's a lot of rocket.
That's
a lot of acid.
That's a lot of acid. That's right. This is the acid part of our experiment. So I'm going to scoot this stuff out of our way because we don't need it anymore without blocking my helper Abel here. Okay. Then I'm going to take my tablespoon and I'm going to scoop out a tablespoon, about, doesn't have to be exact, of baking soda. And then this little tiny square of paper towel, which is about 4 inches. We have one of those paper towels. Evie, grab our paper towels so we can show them what we have here. It's one of the ones that has the skinny paper towel sizes, the select-a-size kind, and I kind of just ripped it in half. And that's about the size that we used. I did trim it down a little bit because this is what I found to be the trickiest part. Now, I put my baking soda in the middle of my paper towel, and now you've got to roll up your baking soda in your paper towel, fold it up nice and tight and tiny, and when we go outside to do this, we're going to stuff this into, don't spill it in there yet, we'll get a chemical reaction too soon. We're going to stuff this into the bottle and then where's my cork? There's my cork. Jam my cork in there and put it upside down onto our launch pad right away, all really quick. When I put this in, it will start bubbling. Some of that carbon dioxide is going to escape. But as soon as I put the cork in, it will continue to react and it will continue to build inside the bottle until there is nowhere for the gas to go and it pushes the cork out of the way. Side note, I forgot to mention earlier, if you don't have a cork to use, a substitution that was recommended was a pool noodle. So if you have an old pool noodle lying around, that was hard to say, you can cut that into a piece that will fit snugly into your bottle. Okay, so we're gonna pause right here and we're gonna move all this stuff outside so we can do our rocket launch. Ready? Okay, we are outside. We have our baking soda packet wrapped up. We have a cork. We have our bottle with 2 cups of vinegar in it. All right, I'm gonna ask you guys to scoot back so we are a safe distance away from the launch. And
well, if we see you more.
Yeah, and then we will try and get this baking soda to fit inside this bottle.
Sakari Beats.
You gotta kind of maneuver it in there.
It means the jungle.
All right, so here it goes. I've got the paper towel in. I'm gonna add the cork and turn it upside down. All right, we gotta give it a minute. I think last time we didn't give it long enough.
Yeah, Mom held on to it and shot off in her hand.
Yep. Oh my God. And because
some got on me. That's okay, buddy. This is what is left of our base.
So that was our rocket launch. As you can see, our base did not stay together. Evie, you want to show them what's left of our launch pad here? It did blow the Legos apart. We do have our paper towel right here, and the bottle is over on the other side of the driveway. So because our base, we did not take into account that the cork was going to change how the bottle fit in the launch pad, our launch was not straight up. Our bottle tipped over and it did shoot over across the other side of the driveway. So if we were doing another engineering step, we could recalculate, remake our launch pad and try again for a straight up shot. So I want to know how far and how high your rockets make it. And if you want to send me videos or pictures of you guys doing it, I would love to have those in my email. You will notice that around us on the driveway, there is a lot of vinegar and water that were left over from the reaction that splattered everywhere, which is why I asked the kids to scoot back when we did the launch. Please be patient. Once you've started that reaction in that bottle, don't go over to the bottle until it has launched. If you get a little too close too soon, it could launch while you're holding it. But I hope you enjoyed it.
And you can fly up.
I don't think that rocket's going to take you with it. I hope you enjoyed our sim video. I can't wait to do the next one with you in July. Our next one is going to be the oobleck egg drop.
Yay!
Yes, it's going to be so much fun. It's going to be another outside one, and I can't wait to do it. We'll see you next time, guys. Bye.
Bye.